All right, so welcome everybody. We're going to start a little series here. We're going to be programming in Kotlin primarily, and in order to show you a little bit more about the language, we're going to actually build a fully functioning server from start to finish. And we're going to build a linter bot that can run and use the GitHub checks API so that whenever you check in code or do a pull request or anything like that, you can get it to lint all of the files that you may have updated. And you're going to see those in your pull request as line items that need to be fixed. So we're going to be using this checks API. It allows you to send detailed information about the checks and our integrations and run those against. You can update the build statuses, so you can decide to pass or fail your builds depending on what you so desire. And we're going to basically have rich statuses. We're going to annotate the exact lines that are not passing the lint checks. And we're going to follow this kind of tutorial or introduction, if you will. GitHub actually has a pretty cool sample project that they have in Ruby that essentially does this. And we're going to do this in Kotlin specifically for Kotlin projects. So we're going to be using Gradle as our build tool. We're going to set up a multi-module Gradle setup. We're going to set up a nice dependency structure so that you can manage all of your dependencies easily between all of those modules. And we're going to be using Vertex as our toolkit or our web framework of choice. You could really use anything you wanted, Spring, Micronaut, any of those. I simply choose Vertex just because I like the toolkit itself. I like how it comes together. It actually is polyglot as well. So if you prefer to use JavaScript or Groovy, Ruby, Scala, whatever it is, the API is the same, which is really interesting. This isn't something that I have done in practice and in production, but this is a really kind of interesting aspect of the Vertex toolkit. So I have a repo up on my GitHub, ktlint, and so this is what we're going to be working out of. I will tag each of these streams with each day when we end the stream, so you can check out the code at each point and follow along. And this is just I just threw in a to-do here before we start, just so that we can maybe keep track of a little bit what we're working on and what you see and kind of where we are in the process. So let's get started. So we're going to start from a blank project. So again, this is an empty project, and I'm going to show you how to go through this start to finish and how to set up your project in such a way that will kind of work with you and grow with you over time. So first thing that we're going to do is we're going to add a new module, and we're going to pick Kotlin. It's going to be a JVM module. This says idea native. Actually we want to do a Gradle module. We're going to say Kotlin for the JVM. I'm using Java 12. There's nothing in here that won't work all the way back to Java 8 if you want. So you can go back all the way to Java 8. But so we'll select, we want a Gradle project. We want to use Kotlin on the JVM. Go ahead and hit next. Our group ID. So this is going to be our package name. So I'm just going to have this be com Z Siegel. The initial artifact is going to be ktlint bot. So this will hold all of our code for the actual server or bot that actually runs, has the webhook that GitHub will call. And artifact ID, yeah, module. So yeah, ktlint bot will be our module name. Actually, we'll call this webhook. Is probably best. So this is where we'll hold our webhook. So we'll go ahead and finish that, and then we'll take a look at what it generates, because what it generates is okay, but it isn't great, especially as you add more and more modules. So let's take a look at what it created us. So it created us essentially two files. We've got a build.gradle file and a settings.gradle file, which isn't much. So you're kind of on your own for the rest of this. So let's go ahead and play with this a little bit. So let's go ahead. There we go. So this went ahead and created us a source folder. This is kind of the standard Maven project structure. Source main, it has both Java and Kotlin. So let's go ahead here. We're just going to create a new Kotlin file here. We're going to call it main, and we're just going to basically show that we can run this. Right, and then basically in IntelliJ, it's nice you can just hit this little play button here. So what this is doing, this is going to build and compile this project, and it's then going to run. So we have right now a single module Gradle setup, right? But what we really want is a multi-module Gradle setup, which when we add the second module, things are going to get a little weird, but they won't be too difficult to fix, right? So, so as of right now, right, we have a single build.gradle file. It's saying how to build this webhook module. Our only dependency is our Kotlin standard lib JDK 8. And we have our compile targets. Now, when we create another module, we're going to want to clean a lot of this up, because a lot of this is going to get duplicated, right? So let's go ahead here and create a new module. Again, we want another Gradle module. It's going to be a Kotlin JVM module. Add module to ktlint bot. Great. That's all fine and good. This artifact ID, we want to be different. So what we're going to want to do is we're going to want to put all of our code that interacts with the GitHub checks API in here. So let's go ahead and create this separate module, lib GitHub checks, and finish that. And so immediately this is going to break here. We're going to enable auto import. Immediately this is going to break, right, because it has duplicated a bunch of things that were in the previous one, right? So this is where we kind of have to fiddle around a little bit and make this nicer. So what we really want is all of this duplicated stuff to be in the root, and then we need to move our our source folder, our webhook, into its own module, right? So let's go ahead and do that. We're gonna we'll just create a directory, right? Because we're just moving things around, and we're gonna take the source, the build, and the build.gradle, and put this into webhook. Okay. Okay. So if we go ahead and we ask Gradle to relook at this, it's not. Yeah, so it will not really do anything different, but it won't complain, right? So that's because we need to tell it to include the webhook, right? So if we tell it, it's going to redo itself, and then basically this will show up now as a module, right? So so now what we need to do is we need to start moving or refactoring the stuff that's in here and in here, right, into a Gradle file that's kind of at the root, right? And this is where we'll keep a lot of our stuff. So we're going to go ahead and create a new file, and basically we're going to call it build.gradle, and this will be at the root, right? And so we're going to have a bunch of different things in here, right? So first thing we're going to add is a build script. And and this is kind of what tells Gradle how to, or it's what introduces a lot of the information to the actual Gradle build tool before it actually runs your build, right? So this is where we'll tell it where, its dependencies or class path dependencies need to be, right? So we are going to add a repositories block just to tell this, hey, this is where you can get things. And we'll use Maven Central and we'll use JCenter. Those are the only two we're going to add. And then we're going to also add we're going to add the Kotlin Gradle plugin, and then I think that's it for now. We'll probably add another thing here later, but for now, this is probably all we're going to need. So we're going to add or JetBrains Kotlin Kotlin Gradle plugin. And let's see what version this is at. Maven Central Kotlin Gradle plugin. What version is this at? 1341. I get that right? Yeah, 1341. So Kotlin, ktlint. No, that's what we want. All right. Plugin, yeah. Okay, we'll fix that later. Okay, so we've added this here, and now what we want to do is now we can start basically refactoring the things that are in the project ones, right, and make them kind of slim down, if you will, right? So let's split all of these so that we can see them. And let's take a look, right? So what are some of the things that are in both, right? So this plugin, right? So that's definitely one that's there. So we can actually just get rid of this. And what we're going to do is we're going to apply that plugin here instead. And because this is the version of the plugin that we said, right? That's the version that we use, so we don't need to bring that along. We can also remove both of these repositories blocks because those are definitely not needed either. And so we can also just pull this down here as well because it's the same thing. So now both of our projects have access to those things. What else? So it'd be nice if we could get rid of these blocks. These are the compiler blocks that tell the Kotlin compiler, what JVM you're targeting and allow you to add flags and certain things. So we'd like to get rid of both of those. And so this is where we need to use this thing called Gradle.projects evaluated. So basically, Gradle kind of runs in multiple passes. And the first pass, it basically just is looking at the build itself. And then the second pass is where you get information to all of the projects or modules, if you will, that are there. So basically, we want to look at all of the projects that are evaluated, and we want to say all of the projects that have the type. No, we don't have to do it this way. What we can do is we can say apply basically this compile Kotlin block to all of the projects. So for example, we can then add Kotlin options. So before we had JVM target equals 1.8, I believe. And so that should be fine. The other thing I like to add is warnings as errors. And so basically this will make sure that you are handling warnings from the compiler, at compile time when you should be handling them, and not ignoring those. So we are going to put those there. What else might we want? I think that's it for now. So now we basically have our all of these options get applied to both of these projects, right? So now we have nothing in here that's different. We can go ahead and get rid of this group and version. We're not really going to need those. And now, as you'll see, our dependency block is basically nothing, which is kind of cool. But we do have some duplication here where this dependency, one bad thing is that it doesn't have a version on it, right? We want to be specific about our versions. But the second thing is that this is also duplicated. So how would we go about this? So back in our build script, and we can also pull this out as well. So what we want to do is we want to make sure that all of our dependency versions and things across modules are the same if they can be, right? So one way to do that is in our build script, we can define a block called ext. And so this block is going to be available in all of our projects and at build time, and it allows us to specify essentially variables and things that we can access, right? So in our ext, we might do something like declare a something called Kotlin plugin version. We might set that to 1.341, and then what we can do is we can actually use this here with the $sign plugin underscore version, right? And you'll see you'll get autocomplete as well. And so basically now that is going to be used there. And so we can apply the same thing to our dependencies up in here. And so what we really want is we want to be able to do something, we want to access our libraries and have them kind of all be declared in one spot, right? So let's go ahead and just look at, so there's also so if there's a plugin version is 1.341, let's go ahead and look at Kotlin as well. Kotlin standard library, that's also at 1.341, right? So that's great. So what we can do is we can then set a variable for Kotlin standard lib. And we usually want to move these in lockstep, but we're just gonna do this here. And now what I'm gonna do is I'm gonna actually create a map of libraries that that each of these modules can grab, right? So rather than typing out this big long string and then using the version number, we can actually just reference kind of like a variable, right? So we're going to create a Groovy map here, and then we are going to define, basically, we're going to say, hey, Kotlin JDK8, this dependency is essentially this. And then we want the version Kotlin underscore standard lib, right? And so now in our project over here, we can actually reference this, right? So we can say libraries.kotlin underscore JDK8 in both of our files. And so now our libraries are defined in one spot. If someone needs to pull in a different library into one of their modules that's maybe in another one, they'll be there. And so then you can control your versions and your dependencies kind of all from one spot in your project, which is really, really, really nice. So that should do it for that, right? So, okay, so what did we do here, right? So now what does our project look like, right? So we have two modules. We have our root build.gradle file, right, which essentially just sets up kind of the framework for the rest of the project, right? So it sets our dependency versions, it keeps track of the libraries that we might use. It sets some compiler flags for all of the modules across the board so that they're all the same, right? And then we have two modules, right? The webhook module, which will host our webhook. And then basically we have our GitHub checks module, which will have all the code related to kind of, all of our business logic, right, for those GitHub checks, right? And then the last thing we have, right, is our settings.gradle file, which just says, this is what the project name, and then basically these are the modules to include, right? So right now we're including our 2 modules, right? We're going to go ahead and essentially just check this off, right? So we set up our multi-module Gradle setup. We also kind of set up our dependency structure, right? Which is great. So now we can tick that one off. So next what we're going to do, so let's read a little bit about how this checks API actually works. So, just so that if you're not familiar with it, you will get a better understanding of it. So, so the checks API allows you, this is something that you hook into and you use typically with a CI server, right? So what's going to happen is you're going to check in some code. You might open a pull request, and then your CI server is going to grab that code, and it's going to run tests, lints, security scans, anything you really want, right? And this is really helpful in teams if you want to enforce code formatting, run the tests, right? Maybe your test suite is really large, and it can be a little burdensome to run on a local machine. But this checks API is relatively new, and what it allows you to do is it allows you to hook your CI server into your code or into your pull request. And so what happens is when this runs, you get let's make this bigger so you can probably see it. Zoom. Yeah. Okay. So basically, what happens is that when this check runs, right, it's going to run and look at all your code, and basically it'll also then comment on your pull request, and it'll tell you that things are good or bad. And in our case, right, it's going to be very similar to this, right? So we're going to see under the checks tab, right, we're going to see that this is running, and then we're going to start to see feedback on those files. So pretty straightforward. We're going to go ahead and we've got some work to do before we can actually use this. But basically the way that this works is that whenever a pull request happens, GitHub, you register your app essentially as a webhook, right? GitHub then calls you and says, hey, this pull request is opened. Then tells you again, hey, here's all the files and here's all the information about this pull request, and then you can go ahead and run your code and then basically call back to GitHub with the status, right? So we're gonna integrate with the GitHub REST API and make this happen, right? So we're gonna need a web server to start, right? So as I mentioned earlier, we're going to use Vertex as our web server. It's a pretty nice, simple, lightweight web server and web toolkit for the JVM. It has really great Kotlin support, and we're going to go ahead and use this. So latest version is 3.7.1, so let's go ahead and add this dependency to our libraries. So Vertex 3.7.1, Vertex Core. Okay, so this is 3.7.1. So now, again, we want this dependency to be done in our root, right? So that we are doing it in the same spot everywhere, so we don't get different versions of things. So we're going to add this 3.7.1. And we're going to go ahead and add Vertex. Now, one thing that we're going to do is, so Vertex is split up into a bunch of different libraries, as you can see here. So there's core, there's web, there's a ton of these things, right? And we're going to actually have to pull in more than one to get the things done that we need. And so we're actually going to define this in another map. so that when someone pulls in Vertex, they get, you know, core and web and a couple things that they need, right? So let's go and do that, right? So this, you know, this is io.vertex colon vertex dash core, and this is $. Actually, I'm gonna put version on these. That was my bad. That way we know what they are. Version. All right, so if we open up our, okay, so what else are we gonna need here, right? So we're probably gonna want web. So let's take a look. Let's go back to Vertex. One of the things, Vertex has incredible documentation. So we're gonna go to web. So web is a toolkit for writing sophisticated modern web applications and HTTP services. Okay, so that's pretty much exactly what we want, which is great. So let's go ahead and add that as well. So we need Vertex web. And let's see, Vertex Web 371. And we're also probably going to want, Vertex usually has language extensions. Yeah, Vertex lang Kotlin. So we're going to go ahead and add this as well. And basically this is just kind of the extra syntactic sugar language bindings that come with Vertex, right? So if we package all these up in a map, the cool thing about this is then we can go back to our webhook, right? And then we can actually just bring in all of these libraries by just libraries.vertex. So now, rather than like listing each of those things out, we got access to all of these right here, which is pretty cool. So let's go back to the documentation, and we'll go through you know, again, I'll go through this documentation here because it's actually really handy. It works, you know, they have really good documentation, and we'll kind of go through this, right? So let's see if our dependencies and such are working, right? So let's do this. So let's say val server vertex.create. Actually, we're going to need to oops. Ooh, what is going on with my keyboard here? Vertex. And we can just pull in core for this because there's nothing fancy we're going to do on here. And we're going to say create create HTTP server. Actually, we're going to do this. So let's store our Vertex instance. Vertex.vertex. This is complaining about JVM target 1.8. Okay, so this is IntelliJ complaining about our JVM project's targets. So we're going to go ahead and we're going to fix that here. All right, so let's fix this. So we told Gradle and Kotlin that we want what our target to be, but IntelliJ doesn't know that. Module settings, projects. Actually, we're going to want that set to 12. This set to 12 as well. Why are you complaining about this? Calls to static methods and oh, you know what? It's because we told. Is that right? Kotlin options JVM target 1.8. Maybe it's because we need to tell. This is interesting. Task dot with type. Let's try something here. Compatibility equals 1.8. Oops. And then let's make this target compatibility 1.8 as well. Still complaining. All right, this has got to be an IntelliJ, or yeah, this has got to be an IntelliJ problem. I don't remember. Why is this complaining about this? Maybe it's the Kotlin compiler in here. Yeah, there we go. Kotlin compiler, we'll set it to 1.8 even though we're using 12. But no, still don't like that, huh? Kotlin to JVM 1.8. 12 modules. There we go. 1.8. The two modules in the same content root. Okay, I'm just gonna that's weird. What the heck? Can't do an order webhook libhop. This is probably just something with, I'm just gonna do this and basically, well, either that or this is an IntelliJ bug because I am running on the betas, which would be kind of funny. Let's go ahead and give that a whirl. Settings again. Yeah, this is definitely a beta bug. This is because this is broken. Okay, let's get ourselves the let's get ourselves a stable version. Oh, beta software. Okay. Not beta software. There we go. This should be beta. Open. ktlint bot. No, don't need tips. Invalid JDK configuration found. Gradle. Gradle JVM. Use project JDK. And that should do the trick. Oops. All right, so yeah, okay, that is better. So let's, all right, yes, it's not complaining, but our fonts are all screwed up. So let's fix that. Font 16, 1.2, font ligatures, Fira code medium. Actually, let's bump this up to 18. It'll probably be easier for other people to see. Okay, there we go. Oh, still complaining. All right. So let's go back to here. Use project settings. This is 1.8. No. All right. That is cool. Edit project settings. 1.8. This has got to be a bug. Content root is defined for 2 modules. Okay, let's just get out of here. Oh, you know what? It's because we moved. It's because we moved this stuff around. Yeah, let's get rid of this. It's because we moved this around. 1.8. Yeah, there we go. It's because we moved that thing around. And it was just complaining that it didn't like this. Okay, so now we should be able to fix this. It's broken again. Project default. All right, well, this is pretty silly. I don't know why this doesn't work, but this doesn't really matter. This is, you can just ignore this. So let's go back to our documentation here. So we're going to create an HTTP server. And then we're going to put a request handler here on, actually this isn't the, yeah, that is the request. So now let's do, so we're just gonna do a response and test this out and run this locally. And for now, we're just going to listen on ports 8080. All right, so this is kind of what I love about Vertex, right? In order to just spin up a web server, very reminiscent of kind of Express or some of those frameworks that you may have used on with Node or Go or any of those. So let's go ahead and run this and just check that our server is working. Oh, so this really is going to complain. Oh, it's because we have errors as warnings on. Yeah. Okay. So we actually have to fix this. And this is going to drive me nuts. Why? I'm going to say load, unload modules. No. All right, let's just do this. There's something funky with this. We're going to invalidate and restart and have it find everything. Something's goofy. Something is goofy. This is what happens when you mess around with the modules yourself. Okay, it's thinking very hard. Oh, that's the problem. That is going to be the problem right there. Yes, that is the problem. Okay, so at least I think it's the problem. So if we go to here, yeah, this is all in a folder called webhook, which is not what we want. Yeah, that's my bad. That is, well, the problem's fixed, but this isn't what we want. So, or well, the problem's not fixed. We need to fix this. All right, so what we want is all of this up here. Yes, I want to merge it. You cannot, yeah, I know that. So we're going to pull these up and then delete this one. Okay. Yes, that is the structure we want. That is probably why, or a reason why things are all screwed up. So we're going to have it reload everything. Yeah, and now it's going to complain. So let's do this. Get rid of all this, and then basically we will get rid of this, and we're gonna re-import the project. Nope, I don't want to load you. Oh, maybe it's going to figure out. Yeah, import. Use auto import, Gradle wrapper. Okay, so now we are fixed. We're not seeing any errors. Let's go ahead and run this. And when this comes up, we should see, yes, so our little web server is up and running. Which is great. So this will be the, we're going to build off of this. This will be our webhook. At the same time, this is also a good time to talk more about Vertex. So Vertex is a web server or web toolkit, and it's based off of an event loop. So if you've ever worked in Node.js or JavaScript, you have to be very careful about what you do, for example, in this request handler. So everything in the Vertex framework is designed to be asynchronous, which makes how you structure your APIs, depending on what you do, a little bit different, right? So for example, in this request handler, right, I cannot, you don't want to do any blocking calls, right? So for example, if we had a call in here that slept, or say that this was a blocking call that went out to the database or something like that, like this is going to be bad for Vertex, right? So let's go ahead and rerun this, right? And when we hit this, you'll see, I believe, Vertex will complain. So we're going to hit this right, and we're kind of simulating that the request takes 5 seconds, and you're going to see like, hey, Vertex isn't complaining. It's like, hey, you're blocking a thread, and that's because again, it's running in an event loop. So these calls need to be asynchronous. And in our case, we're going to actually use coroutines for this. You can use Rx and all sorts of other things, right? But the programming model is a little bit different. But in return, you can get some really great performance from again, just a couple of threads, right? So Vertex's default is to run, I believe, 2 event loops per thread on your machine. So let's go ahead and check that out. So let's take a look. Yeah, so let's start off with just taking a look at, just so that we understand this right, how many event loops we have. One thing I'm going to do, so I'm going to put this back here, and we're going to run this, and so you're going to see Vertex event loop 1, 5, and you'll see that basically I blocked one of these. But if I rerun this, and I say send a bunch of requests, I don't know if I'm going to be able to trigger it. No, I probably won't. Just because it's not getting enough to move around. Yeah, it's not going to trigger it. Okay, so so one thing that we can do is, or that I always do when I start using Vertex, is I set some options, right? So I want to be really mindful of this, and I want to try and catch anywhere that I'm doing things for anything too long really early on. So the default is about 2,000 milliseconds for blocking a thread. I'm actually going to bring that way down so that we start to see some of these things much earlier on, because a lot of times you'll use an API or a call that's maybe a synchronous API, and you'll think it's fast, but it's really not. Maybe it takes a couple hundred milliseconds, right? And so you really want to be careful with this. So we can actually set our some options on Vertex to control this a little better. So for this, there is something called Vertex Options, and we're going to go ahead and configure that. And there's a bunch of different things that we can set on this, right? So we're going to set the warning exception time to be 1. And if we take a look at this, right, sets the threshold value. Above this, the blocked warning contains a stack trace. So we always want stack traces. So you'll see here, this didn't have a stack trace. So if this is happening in production, you won't know what's triggering this. So we're gonna go ahead and set that to 1. And basically, if we pass this options and we rerun this, and then we block our thread, by setting this, we're actually going to see the stack trace of where the problem is right away, which is pretty cool. Let's rerun this. So now when we run this and the thread, the thread gets blocked, right, this is actually going to tell us where this happened, so we can actually solve this problem, right? So this one's really important, right? Next one we're going to set is the blocked thread check interval. And so what we want is we want this to be, basically we also want this to be basically 1. And then what we can also do is we can set the blocked thread check interval unit, and we can set this to time unit dot milliseconds. Now I usually set, you can set this to whatever you want. I'm going to set this to, 5 milliseconds, right? I want this to be really fast. We might, depending on your workload, depending on what you're doing, depending on your scalability and your latency needs, you might change this around. but I'm going to set this to 5. And so this is going to trigger a lot faster than before. So before it was taking about 2,000 milliseconds. Now if I do this, this is you'll see this triggers it triggers a lot quicker, right? The time limit's still 2,000, but I'm going to set this to set max event loop execute time. We're also going to set this to this, and we're going to set max event loop unit time unit dot milliseconds, right? So we take a look at this. So sets the value of the max event loop execute time, right? The value of the max event loop execution time. So now if we run this, yeah, this is actually, yeah, we got to tweak this a little bit. We're going to set this to 1 second instead. So now if we do this, it's going to blow up real quick, right? And it'll tell us, hey, you blocked this, right? So, hey, you blocked this for over a second. The limit is 1,000, right? So, so again, right, we are basically just setting stricter limits for ourselves in terms of when things go too fast, right? So we're going to set this to 500 milliseconds, right? So we set our execution time to be 1 second, and we're also going to set, actually we should just set this to the same thing, right? And again, you can set these and tune these to whatever you want, right? But we're saying basically if someone blocks the event loop for more than 500 milliseconds, we need a warning, and then we also need this thread check interval to fire. And basically this will also tell us again, and this is basically saying we want an exception every time, right? And the other thing we can also do is we can set the event loop size, right? So if you, so like I said, right? So say we set this to 6. So we go in here. So basically, again, set the number of event loop threads to be used by Vertex, right? So this by default is 2 times the number of available processors, right? So if you have, and this now is actually, this didn't used to be, this now actually respects Docker settings. So if you're running in containers in Kubernetes or in Docker containers or whatever, Vertex now actually properly picks up this processor information, whereas before it did not respond properly to C groups, which led to some interesting problems when you're running in Docker containers, right? So, so we're not going to set this, but just to be aware of it, right? If you're on a 2-core machine, it's going to run essentially 4 event loops. If you're on a 1-core machine, it's only going to run 2 event loops. So that will affect your ability, that affects the scalability of these items, and this is why it's so important to set these event loop execution times so that if you're blocking one of your threads or one of your event loops, that means that you can't serve any more requests, right? This is very different from the other frameworks, typical thread per request models that you may have used in other frameworks. So so that's the event loop. We'll get a heck of a lot more into this as we add coroutine support and things like that. This is actually about as far as I wanted to get. So we're going to go ahead and add that in there. So we won't add coroutine support just yet. That'll be for the next stream, probably in the next couple of days. But we have a working multi-module Gradle project with a nice way to manage our dependencies. We've got our, silly little web server. This will act as our webhook for the GitHub checks API when we start to work in that. And so we're in a pretty good spot. So I don't want to go too far. I will tag this code, basically end of stream 1 on the repo. If you have any questions, if you have anything else you'd like me to cover as part of this kind of walkthrough and tutorial, let me know. And I will see you in the next stream. Thanks.